and thanks for selecting episode 13 of my washing machine series. In this episode I'm going to show the inner workings of Indesit 9kg 1400 spin speed front loader washing machine, automatic, and I'm going to show the inner workings of it whilst it's doing a wash cycle as well. Now, don't do this at home, it's dangerous. You take covers off of appliances that work on the mains, it's potentially lethal. Now, I know what I'm doing, my dad's an electrician as well. This is my idea to take the covers off and do this video, and well aware of the dangers, so I recommend none of you do this at home unless you're an electrician or you know exactly what you're doing. If you know the dangers that's involved, then you need to know that. So don't quote me on this stuff on this, don't quote me with anything regarding this. This video is only for entertainment purposes only. I'm just going to first of all go through the components and what they do and how they work basically. So first thing, I'll show you what the washing machine looks like. So it's an Indesit, that's the model, and I'm going to show this in operation when it's actually working as well. 9kg inverter motor, permanent magnet motor. The insides, the top cover's off. I've also got the back cover off as well. It's belt driven motor, permanent magnet, permanent synchronous motor. So it's a permanent magnet motor, it's a synchronous, and it's basically the main mover for the machine. Covers, there's this as follows. That's the rear cover, and the top cover, which is quite heavy, it's sort of like a sound ending material. There's a couple of screws around the back that hold it in, and there's 6 screws that hold this sheet steel back plate for the back cover panel. So what I'll do is I'll jack the machine up, I'll tilt it to one side and I'll get a view from the underside later on. First thing I'll do is go through the components on the machine and I'll give you my understanding of it. So this is just like a cross brace, just to stiffen the sides. It goes over, it's just a thin gauge, but it's just there as a support. Cold water will come in from the back. It's fitted. It's basically just screwed on and tightened up with pipe grips. You've got the inlet valves, solenoids. There'll be 2. This is unplugged, by the way, so there's no power going to it. The water will come in, that'll be the valves that will close or open, depending on what side it wants to go in. The water will come in through this channel into the soap dispenser drawer. You've got like a pre-wash, you've got the main wash, you've got a softener, which is still got a wee bit of water left in it. So figuring out what one is what, I would guess, let's see, can't really see, but I think one of these solenoids will control this side anyway. The other, there'll be a channel, there'll be 2 channels. There'll be a channel in there for the pre-wash and the main wash. And I think both solenoids open, which open the valves to allow the softener to come in. That'll be like both jets will somehow cause that to happen. I wonder if I should just take this out and see if we could have a closer look at what's going on. So it's hard to really but the water will come down from there anyway. So that's the back of the drawer. Just goes in, pressed in on that and it releases, pushes back in. It's that simple. So anyway, that's your water inlet. It'll go into the drum with this pipe here. It'll come down from the bottom of the soap dispenser. If I could get the camera down there to show you, I'll try. And certainly not taking this washing machine apart like the old one that I've done in previous videos, because this one is still in use. It's got quite a lot of work to do. You can see the water, how it comes down in that pipe there. So it goes into the drum on the front side. So once it's in the drum, fill up to its preset level, which will be, if I could show you. So the preset level is determined by this device here, which is the pressure switch that will detect how much water is in the drum. So it will set up a pressure in this pipe here. So as the drum fills with water, the water will cause a pressure difference in this pipe. This pipe's connected to the drum further down the outer drum, so down there somewhere. I can't really see it at this angle, but it will be connected up down there somehow. And as this pipe, the air in this pipe will start to pressurise, which will act on a diaphragm inside this pressure switch, which will either close or open the switch, will close the circuit, close the switch, close the circuit, send a signal to the motherboard, which is here, and this motherboard will then tell the solenoids to close to stop the water from going into the drum anymore. So that's it. That's when it's filled up to its preset level. That's determined by the motherboard and the program selected. So once that's done, the drum is going to use a heater element at the bottom here. That'll be the temperature sensor, I guess. That'll be the heating element wire, so that'll heat the water, that'll detect the temperature, and it'll send a signal to the motherboard to tell it it's reached the temperature, the preset temperature that you've selected on the temperature gauge, temperature selector rather, for your program. Okay, so once the water's up to temperature, the drum will be driven with this motor at the bottom. That's the motor, permanent magnet motor. 3 wires going to it. That will turn the drum one way, turn the drum the other way, and it'll do the spin speeds as well. The drive's taken from the motor via this ribbed belt, which will drive this drive pulley, and that drive pulley is connected to a spider. It's basically a brace in there that goes on the circumference of the back of the inner drum, so it spreads the load. Rather than try to turn it in the centre, it could twist, so the load's spread out, and I think I'm guessing it'll be the same as the old one. There'll be 1 to 120 degrees apart. Most washing machines, I think, are like that. It's connected there, and it transmits the turning force to the outside edge of the back of the inner drum, so that it's turning on the outside rather than turning it in the centre, because it could twist. So there's a couple of bearings in there. There'll be an inner and outer bearing, of which the inner drum will be resting on. It supports the inner drum. So at the back you can probably see you can see the 1, 2 and 3, 120 degrees apart. See if we can zoom in better. So that's connected at the edges, at the ends of these. It's where it's fixed on the inner drum, so it's getting the torque transmitted at that corner there. Rather than transmit the torque in the centre, it just transmits the torque. It's fixed to the back of the edge, the back edge of the rear of the inner drum rather. So the back of the inner drum circumference edge is where it's fixed to. On the other side of there is the spider. They call that a spider. It's a 3-legged. I've shown it on the earlier episodes on an old washing machine. You could see what it looks like earlier on in the series. So the washing machine drum is suspended. The outer drum of the washing machine, which contains the inner drum, that is suspended on 2 springs, known as the suspension, that allows for movement, for the movement of the water and the clothes moving around inside the drum. And it's achieved by the spring, which is fixed to the chassis, or the outer edge of the top edge of the machine bodywork. You can see that. And there's one adjacent to it on the opposite side. That there's so it doesn't bite into the metal, it's got this plastic. And the reason on the old machine that was scrapped, this one has rubber to stop it eating into the material. Because on the old machine, it just ate into the material and it was ready to collapse. I'm not really sure this is going to hold up as well. I don't think things are built to last that long these days, in my opinion, compared to the old stuff. That's just my opinion. But you can see how it's fixed on. I reckon it should have, in my opinion, maybe more springs, and probably more material between the top of that, between that and there, so there's more lastability. Because in the old one, on an old machine, it just ate through and nothing was really cave in, and that would be a disaster if it collapsed. But when this is, well, you know, you get what you pay for really at the end of the day. There's a bit of info. Trying to get the, can't really get the camera down there. That's better. And I'm with the model of what's this weight that. So on the drum you've got at the bottom of the drum you've got shock absorbers. It's difficult to see in this angle, but that supports it, the drum at the bottom. They're air filled, and that basically limits the amount of movement that the spring does and supports the bottom of the outward washing machine drum. You can see it there. I'll try and get the thing up on one side so I can get the camera underneath it as well. So the drum has also got, the outer drum has got these counterweights, and it's held on with 3 bolts at the top. There's a counterweight on the front face of the outer drum. If we could zoom this in, you might see the concrete. It's not very clear. It's not very clear at all, unfortunately. Try it again, see if we could zoom in a bit better. There, so that's the concrete. Oh, goodness sake. Third time lucky. Try again. No, okay. Well, you could just make it out anyway. It goes round in a crescent shape. It did it. To the other one that I took apart, the old one, it went down like that. It was shaped like that, and it was fitted onto the front edge of the composite material outer drum. And like the old one that I took apart, this drum doesn't look as though it's serviceable. So if the rear bearings go on it for the, you know, the bearings for the drum bearing, the washing machine drum bearing, that's what the inner drum is bearing or rested on against the outer drum. If the bearings go, it's got to be split. You've got to remove the inner drum in order to access the bearings. Well, on the old washing machine, on the old one that I took apart, I had to get the thing angle grinded to get the inner drum out, which means it's sealed for life. On some machines I've seen bolts, screws that go around the circumference where you could actually split the two. But on this one it looks as though it's sealed for life. So if the drum bearings go, I think the machine is knackered completely. It's a preset life. As I say, you pay for what you get. You get what you pay for. Well, that's the saying, isn't it? If you're lucky, you get really what you're... But anyway, enough on that. Looking down, make get a better view of that concrete block now. There you go. That's the front weight, counterballast weight. I was trying to emphasise it. It's the same material as the top one, but I just kept going out of focus earlier, but you can see it now. Hopefully you could. So that is that. Now the next thing, when it's coming to empty, when your motherboard here, this is your circuit board, it's got a microprocessor and everything behind that. It's certainly not going to take that apart. You can see earlier ones in my earlier episodes in this series of the microprocessors on an old washing machine, but I don't think you could even see it down there through the gap. It's just wiring harness. But your switches and dials are all basically pegs that will make contact with switches on the circuit board. Judging by the old one anyway, an old one that I done on an earlier episode, I assume it will be the same on this one. So anyhow, when it comes to emptying, the pump, which is not really visible at this moment, maybe now, there you go, there's the drain pump. That will drain the water. As it will displace water, water will run down from that black pipe. Again, keeps on moving, this blooming thing, right? I want to know what that is. I want to get a closer look at that, but I'm going to have to jack the machine up. But that looks like the sump pipe. So water will run down from the bottom of the drum into the pipe inlet, the pump inlet, which is there. The pump will just basically pump the water up through the outlet, which is connected to the pump. Not very clearly showing you this very well, but you might just see it there, the pipe connector. The grey pipe anyway. Silver one's the inlet for the drum. The inlet to the pump is that one. The outlet to the pump is that one, the grey one. And from there, it will go along the pipe, the grey pipe. Oh, this is so awkward. Right. That's the grey pipe there. That runs through the back of the washing machine. It comes out there, follows its way along to the drain underneath the kitchen sink, and it just gets drained into the drainage system. Because this machine's plumbed in, the inlet water comes in from there, by the way, as well. It goes into the back of the machine. But it's plumbed in this washing machine. So now, when the machine's working, you've got a door interlock system. That there makes sure that you cannot open the door while the washing machine's in use. And it runs through here. There must be like a... Now, an old washing machine that I took apart, I saw inside one of them. And I think there's a peg or something that locks against the catch on here. In this instance anyway, I'll go down there, so that when you try and open the door, you try and pull it open. It's not a mechanism, it's such just a pull open. There'll be something down there that will stop it from opening. There isn't a locking handle mechanism on this model. It's just a case of you just pull it and it will open. So there'll be something in there that will move, that will cause this from... So when you try pulling it, it'll be hooked in with the pin or peg or whatever goes down there. Stop the door opening during the washing machine being in use. This red light will illuminate to tell you that the door's interlock is on. And that's the door interlock down there. A couple of wires going to that. Well, there's a few wires actually. There's 3 wires. That goes to the wiring harness. It's maybe just going to get its power from the... Well, there is a motherboard, a circuit board down there as well, by the way. You've got the control board on the top, but there is another circuit board down there. It's not very good to show on this, but... So that's the other circuit board. I don't know how this is coming out. Not very well, I don't know. But I'll have to jack it. I'll have to put the machine on its side. But that there, behind the plastic, that beige coloured plastic cowling, there's another circuit board. So you might see the wiring going into it. If this blooming thing will stay in focus. It's just not really doing me any favours just now. Right, it's no, it's just going to keep going out of focus. There we go. Well, anyway, you can see it, kind of. I'll put the machine up on its side a wee bit. Not on its side, but I'll tilt it over and get the camera underneath. So that's the belt driven, the drum is belt driven, that's the type of belt, I think I mentioned that already. I'm going to tilt the machine over on its side so I can get a view underneath. Just before I do that, just prior to doing that, I'm going to show you, that's the, I think there's a capacitor in there or something, a suppressor capacitor, so it doesn't interfere with any other electrical components. I'm not 100% sure how that one works. I'm not quite sure what that is. My dad will know, but I don't want to distract him just now, he's busy. My dad is an electrical engineer, he knows this sort of thing. But this is my video, so I've got to just give you my explanation on it, because it's my idea to do this, so. Right, I'm going to tilt this over and get a better view of the underside of this. And then after that I'll put this machine on, do a wash, and you'll get to see the components working. Don't try that at home, by the way. I have to emphasise that, because the voltages in there are lethal, there's moving parts in there, this could do you serious harm. So you don't want to be doing this at home, unless you're a washing machine repairman or something, you know, I wouldn't advise you doing it. Right, I managed to catch my dad before he went out. I asked about that capacitor thing on the back of the machine, what I thought was a capacitor. It's a mains filter. It basically filters out any interference, because there's a lot of heavy current and loads going on at the washing machine, particularly the motor when it's initially starting, and you know, when it's about to turn, that's when the motor's at its maximum load. You've got the pump, you've got the motor, you've got all the elements, mainly the motor, heavy current stuff. That would cause up a set of an interference with the rest of the electrical things in the household, because of the power surges and stuff. So that electrical filter there, what I thought was a capacitor, does a similar job. It's just a filter out interference, basically, so it doesn't affect your other household appliances, like fragile, delicate, sensitive stuff like computers and that. Because power surges with sensitive electronic stuff is a no-no. They don't go very well. Causes things to glitch and all these kind of things. In the modern household these days, there's lots of electronic things, and you don't want to have power surges going on when your washing machine's on. So that electrical filter is there to eliminate that problem. Well, that's the filter I was on about earlier on. So my dad's actually going to be out now, he's got a lot to do. I've got to be quick with this now, because I've got stuff to do later as well, so I'm going to have to quickly get this thing tilted over, get a look underneath, then I'll get this machine on, get the wash on, and I'll record the footage. Right, so I've jacked the machine up on its side a little bit, just rest it against the sturdy toolbox. I'll go and get a look underneath now. I spent particular attention to the drum doesn't rest against the plastic for the circuit board down there, so making sure it wasn't touching that. So looking underneath this, you can see the other circuit board. I think that might be the motor module, and it could be the main circuit board for the whole machine. The motherboard, I don't know. I thought the control board might have been the one on the top, could have been the motherboard. This might be the motherboard. They might both be working in conjunction, I'm not sure yet. But that, the drum isn't resting against that, because it's obviously tilting on its suspension. There's a much clearer view of the bottom pipe, called the sump pipe, from the bottom of the drum. That feeds the drain pump. Much clearer view now. Goes into the pump, and then the pump just pumps it along that grey pipe and out into your, under the sink, down the drains. Basically that's how it's done. The pump just does that. The shock absorbers, that's these struts there. There's only 2 on this model. The old one that I took apart had 3. No, I can't really, because I might tilt it the other way later, but you get a better view of the motor. That's the drive motor. You can see it's considerably small. I could see it's considerably smaller than the AC universal. This is a permanent magnet synchronous motor. It's all sealed up, closed off, this casing, because there's a magnet in there. Magnets will attract ferrous metal. You don't want that going inside the motor, so they have it all sealed. The AC universal motor was open, so the windings were able to cool down.
Not quite sure how that one does, how it cools down when it's all sealed up like that. There isn't even a tachometer on the back like the AC ones of the AC wind, well, the one with the field windings and rotor windings of the old one anyway that I looked at, and I think a lot of others as well, have a tachometer on the back which measures this rotor speed. Basically how fast the motor's spinning, tells the motherboard how fast the motor's going, so whether or not to apply more load, more electricity, more power to it. If the motor's under load, it'll get more power to maintain speed. If it's off load or less load, it'll give it less power to keep the speed constant. I'm not quite sure how this one does that because there isn't a tachometer on it, but there is only 3 wires that will power it, and it must monitor the amount of power that it uses to determine how fast it goes. The motherboard will monitor that, how much current power it's using, deter the speed. It could only be, oh, I could figure. That's the bottom weight, by the way. I can't really point it at the moment because it's quite awkward, but you could see it. And it fixes to the bottom of the front lower edge of the washing machine outer drum, the plastic composite outer drum. These 2 wires, that's what powers up the drain pump, the pump, and you can see it's going into that motherboard there. So that must control the pump as well. Tells it when it go on, when it go off. That beige coloured motherboard thing there that I'm looking at, the wires coming out there going to the motor. There's also going to heater elements as well. So I think that must be the main module for the washing machine. And the control board at the top is just sending commands down to that. Whereas on the old machine, the motherboard was actually at the back of the control board. It was a microprocessor, but on this one it looks as though it's down there. I don't like it being down there because it's lower at the bottom. Water could run down into there. It's more prone for getting damaged being as low down as that as well. Pump drain hose right next to it. This is my opinion anyway, but that's how they've done it. That's the setup in this thing. I just don't think they're really built to last, this one. We'll see how we get on. We'll see how it goes. We'll see how this machine will get on. So there, maybe you see the other shock absorber. It's not very clear, but that's the best I could do. I'm not going to bother turning it over on the other side. I'm just going to get what I can. To access the pump, there's a kick plate, a lower plastic panel that comes off so you can take the drain filter out of the pump to filter water out manually, and that is done with the plastic kick plate there. That comes off, this lower ballast comes off. So I think actually what I might do with this video is I might make this video episode 13 showing you all the parts. Episode 14, the next one, I'll show you this machine actually working with the covers off. So this is just going through all the parts in this episode. The next one, I'll show you the machine. Oh, you know what, I don't know, I might even just keep it on this episode as well. I might do that, I might not, I don't know. I'll decide, I'll think about it. But anyway, there's a view underneath. I'll just keep it on the same episode. The heck, mate, I'll just put the machine on and show you the thing working in this episode as well. It'll be a long one, but keeps everything nice and neat and tidy. Everything's together that way. You see the parts before that's used in this episode. It's easier for me to compile as well. Anyway, I'm going to get some still pictures of this before I put it on its feet. Yeah, come on, I'm going to tip it the other side as well and get a view from the other side. It'll just bug me if I don't. It'll be saying, I should have done that, I should have done that. So yeah, and still on the same side, I'll get a look from underneath. I'll tilt it the other way in a minute. I'll just get some more footage of this first. I can't really see what I'm filming, so I'm just guessing what I'm doing here. I can't see very well at all at this angle. It's extremely awkward for me anyway, so I'm just doing my best with what I can do. As far as showing you the underside, I do not want that machine falling down on my hand because it will almost certainly break my wrist because of the angle in it, so I think I'd better not come off of there. It's about 71 kilograms of that. So that was quite awkward, that. I'm going to tilt it the other way and get a view of the other side. That washing machine weighs about 71 kilograms going by the handbook. And another point worth mentioning as well is when the washing machine's actually working, it's got a 9 kilogram weight
load in it, plus the weight of the water. Estimated about 20 litres, 20 litres of water. We had a couple of stones. It's about £10 for a gallon of, well, in weight. 1 gallon of water weighs about £10. It's 4.54 litres in a gallon. I think it's like 50 litres on a wash cycle. It does 3 fills, I think. Roughly average about. I'll probably do 20 litres in the first one, and maybe the remaining rinses will be a little less. So we'll say 20 litres of water, so it's about 4.5 gallon. So it's about £45. There's £14 in a stone. So it's about 3 stone of water, I think, something like that. Then you've got 9 kilograms. No, that can't be right. Hang on, let's figure this out. Trusty calculator. Right, there we go. 4.4 gallons, so 20 litres. I'll show you the calculation, right? So we'll say the first wash is 20 litre, right? 20 litre of water the drum fills up to. So when it's done its first wash, 20 litres, divide up by 20 litres of water, divide that by 4.54. 4.4 gallons, times that by £10. It's £44. Right, £44. Divide that by 14. 3.1 stone. Then you've got 9 kilograms on top of that. 9, so it's divide that by, so 6.3 kilograms in a stone. So 1.41 stone plus 3. 4.5 stone. Jeez. That's incredible. I didn't realise that. 4.5 stone is what's sloshing around in that drum. Payload. But it doesn't spin at that, obviously. It does its wash. So you've got 4.5 stone plus 71 kilograms. So 71 kilograms is the rough weight of that machine. That's 11.1 stone plus 4.1. 15.2. Jeez, that's not far off. That's getting on for the weight of me. Well, I wish I was that weight, I'll tell you, but just another 2.5 stone more, and it would be my weight. I like to think I am. It's more like 3, but unfortunately. But anyway, besides the point, it's a lot heavier than one might think initially. But anyway, there you go. I'm going to tilt it over on its other side and have a look from the other side now. So, tilted over to the left now. Let's have a look under the right hand side. Right, so that's a bit difficult to see earlier, but again, another view of the motor, a different view. You can see the bearings, the bearing on the back of the motor, that's the rotor bearing. There's one on the front as well to support the rotor arm, which has got the permanent magnets on it. And you can clearly see the wiring on the motor, 3 connector block and 3 wires going in, internal wires built onto the motor itself. There's a clearer view of the pump as well. There's a ball, I think there's like a ball bearing, not a ball bearing, but a float ball in there at the top to act as a one-way valve to stop water going back into the drum under certain circumstances. It's like a part of the anti-siphoning. There's a closer view of the motor as well. Let's see if we could spin it out a wee bit. I hope this is a good an angle. I've done a demonstration on how the pumps work on earlier episodes of my washing machine series. I think I've got pictures of that already. Oh, it keeps going out of focus. Anyway, I can't do much about that now. I'm going to have to get this machine on because it's getting on for time. And you can see the weight, the concrete weight there, just it's melted onto the front edge of the outer drum, composite made out of the composite material. Outer drum, that's what the outer drum is made of. The inner drum of the washing machine is made out of stainless steel. That's why it's shiny and keeps it from stain free. It's a stainless steel inner drum. Right, I'm actually going to decide I'm going to make this episode solely for showing the parts. The next episode, which will be episode 14 of my washing machine series, you could get to see this machine working with the covers off, because this video is going to be just way too long. It's already 35 minutes, and that's without rounding it off and without the photo slide. So I want to get a good in-depth view of all the parts working on the next episode, so the video isn't way too long. So I'm going to split it up after all. So I'm going to maybe just get a couple more photos, summarise, and then I'll do the next. I'll put the machine on and show that in the next episode. So I think I've done most of it. They've got the door seal. I'll put this machine right side up first of all. Right, so I've got the machine right side up. So just a wee summary. Go over everything again. That was just the way to say that's the door seal, the main door seals. That fits onto the outer drum with this spring tensioned spring that clips over the whole circumference of the seal. And on the other end there's a seal. You might just see the spring down there if this thing will focus, which it doesn't like to be doing for whatever annoying reason. There, you might just see it. That's, oh, for God's sake, right there. That there, you have to take that whole spring right off the whole circumference of the panel. I'm not doing it obviously, but I'm just showing you where it is. That's what the front edge of the door seal, that's how it fixes to the front panel of the washing machine. And then on the other side it fits to the front of the outer drum with this seal that goes around there. It's quite awkward. My dad's done them before on various machines. They are awkward to do. But, so I thought earlier initially this was a motherboard here, but then come to think of it, right, there's not very many wires on there, so that isn't really going to have much things going on, eh? That's just a control board. That's just going to send controls to, commands to the control board down there, the motherboard, if you like. See, this is the control board for like what you, the operator of the machine, that's the buttons, the settings, and that's all this board is responsible for. It's got the display, well, it's not even got that, it's only got these lights, the row of buttons, your dials, and all that is only 5 wires come out of that. That's it. I should have realised right away when I saw that. There's hardly anything on it. It's just switches really, and it just sends signals. It might be CAN bus or something, I'm not sure. But you think about all the buttons and settings on there, right? All your programs, and there's only 5 wires. So I think that's CAN bus. I think they eliminate wires by using, I think it's CAN bus wiring. And not, don't quote me, I'm not an electrician or a washing machine repairman. It's just using this is just my explanation and my guess. It's my video, so I've really got to give you mine on it. That's the door interlock again. But yeah, I think the signals coming out of this go down through the wiring harness along the edge. It'll be all insulated down into the brains. So that's the actual brains of the washing machine in that casing down there. That controls everything, the motor, pump, when to fill the drum, when not to fill the drum, temperature, everything, all the thinking goes on down there. The microprocessors are all in that casing down there that I tried to show earlier. And this, on the old machine that I took apart on earlier episodes, there was a microprocessor and a whole heap of wires and connector blocks and relays and everything on this front panel circuit board. But on this model of machine, it's different, considerably different. So I'm still a wee bit disappointed with the fact that there isn't very much material. That's the reason an old machine that I took apart was scrapped because of the material at the top of that hole was just basically worn through, and that spring was going to come right through, and it was on this side. When the drum collapses, it's a disaster. So the machine was written off, so to speak. The only advantage with this that I could see over the other one that I took apart is it's got this plastic shrouding, which might help it from prevent it wearing through this rather thin light material. It's not that thick really. I'm not overly confident that this is going to be built to last as long as I would, I just don't think it is going to. But then you get what you pay for, if you're lucky, that is.
That's just, as I say, don't quote me on anything, this is just for entertainment purposes only, this video. The belt's fairly self-explanatory. You can see there's a pulley ratio, you've got a pulley size on there, the diameter on there versus the diameter on here. There's your gear ratio, pulley ratio. So the torque, the motor will spin considerably faster than this. So you're multiplying the torque. So as for all the number of spins that a motor does, you're getting less spins on here, but all that energy is compacted into torque, turning force. So this will go slower. And the relationship between the speeds will be the number of times more torque you get. So it'll go slower equally. The proportion of the slowness of this will be proportionate to the increase in torque you'll get. Turning force is torque. That motor will spin fast. This will spin slow. But all these spins from that motor will be, all that energy will be added up into one or fewer revolutions. So for every many turns, I don't know what the gear ratio is for them, if I don't fall over, that is. So I don't know the gear ratio, but you get all the turns on there adding up to make one turn on here. So all the effort that motor's doing is producing one turn. So it'll go one turn which is slow, but there'll be a lot of force behind it. Turning force is measured in torque. That's why it's big pulley, wee pulley in the motor, big pulley in the back of the drum. Rubber belt is the means to. As you see, you never do this when the power's on, obviously, because it's unplugged. I know what I'm doing. Now I'm guessing that might be a left-hand thread, I don't know. But then it wouldn't matter, because it's going to spin both directions, so be Loctite on that, and sure. But this is made of composite as well, by the way, which is a bit, well, a wee bit disappointed. That's for lightness, but the old machine I took apart was made out of like a kind of cast aluminium or something. I think the motor, there's the front bearing for the motor on the washing machine drive motor. I don't know if I can get the number. So it's quite difficult because things sort of like at awkward angles for me. I don't know if I can even get that, but it's a bit light on again. So I'm taking a photo of it as well. Oh, it doesn't really matter, but anyway, there you go. That's the motor pulley. And you would have saw how the motor was fixed to the outer drum. The motor's got to be fixed to the outer drum because it moves in tandem with it on the suspension. If it wasn't, the motor was fixed to the bodywork of the washing machine, you need a belt and jockey system to allow for the movement. But it's much simpler to put the motor on the bottom of this so that the belt won't come off. It's all connected as one. And it also acts as a balance as well, a stabiliser balance. What the weights are doing, they're stabiliser ballast weights. And the motor will act strategically positioned so that it makes it, it just balances things out a lot better. Keeps everything sweet under here, because if it wasn't for these weights and all the balances and everything, as I mentioned earlier, all that weight in there would just spin this like crazy. This would just shake around and batter everything around. The weights are there to absorb all the movement, well, not all of it, but to help absorb, to control the movement. Because when this is loaded up with water, then you're going to get a lot of movement, and you can see that. Right, so that's it for this episode. I'm going to round it off.
Right, I seriously need to get that machine on now to get the wash on. I need to get the wash on. I shall record the machine as the wash is being done on the next episode. So thanks for watching this episode 13 of my washing machine series. Look out for episode 14 where you'll see it working with the back and top covers removed. Don't do that at home because it's deadly voltages in there. There's moving parts that will do you serious harm as well. So if you're, if you don't know what you're doing, just don't do it. Unless you're a washing machine repairman, don't do it. So I've quoted, I've told you, I can't tell you what to do. I can only say what I advise you not to do. Right, I'll see you later. See you next one. Yeah, bye for now.